Alright, STAAR review number 2. For today's video, we are going to review different types of transformations as well as solving equations with variables on both sides. First up, though, will be our transformations. And transformations include translations, reflections, and rotations. And some of the key words that we can remember: a translation is when you slide an object across the coordinate plane. A reflection is when you flip an object, so it's either going to flip over the y or the x-axis, the x or the y. And then rotations, if you will recall, are a turn. We are turning an object or an image about the origin on the coordinate plane. Okay, so let's look at problem number 1. Problem number 1 says that triangle ABC is rotated 90 degrees clockwise about the origin to form triangle A prime, B prime, and C prime. What is the rule for this transformation? Well, there's a whole bunch of rules, and you can memorize those, but there's probably about 5-6 different rules. So today we're going to review how to discover and come up with the rule by using our strategies. And the first strategy we're going to be using is this patty paper or tracing paper. We're going to use that to plot the points and rotate them, and then from there we can devise our rule. So the first thing we're going to do is we're going to look at one of the pretty points. Now this didn't ask me, the question did not ask me to find all of the new A prime, B prime, C prime. It only asked me for the rule. So if it's only asking for the rule, I can find that out by just using one pretty point. So we're going to use pretty point B right here. So first thing I want to do is I want to write down the original ordered pair. So starting at the origin, the ordered pair is 1, 3. So my ordered pair is 1, 3. Then we're going to go through a process, which in this case is talking about a rotation. And then we're going to come up with a new ordered pair. But now how do we rotate? This is where our patty paper comes in. If you remember, when we use our patty paper, we always want to mark our origin, and then we want to copy the point. And we are moving 90 degrees clockwise, so we're moving in the motion of a clock, and 90 degrees is just going to be one turn. So we're starting in quadrant 1, we're going to end up down here in quadrant 4. So if we rotate it 90 degrees, match back up the origin, that's why it's important for us to mark our origin, and then let's list our new ordered pair. So our new ordered pair is 3, negative 1. 3, negative 1. Well, I want you to take a look at these two ordered pairs. What do you notice? First thing I notice is that my x and y digits, the 1 and the 3, they flip-flop, right? So we can use that information to help us write the rule. Remember, every rule starts out with x, y. That is representative of this original ordered pair. The original ordered pair xy goes through a process, in this case it's rotation, and now something that we noticed, we said that the numbers flip-flopped. Our original x now became the y, our y value now became the x. So we're going to just flip-flop these letters. The y number, the 3, came up front. The x number, the 1, came to the back. So that's the first step. Now we got to look at, did anything change to its opposites? So let's go back to the original. The original x, when it rotated, when it changed, it went to a negative 1. So we started at positive, we went to negative. So after our rotation, my x value changed to the opposite. So we have opposite x. So we're going to put that little negative symbol to show opposite x. My y digits, it was started a positive 3, it stayed a positive 3. It did not change. So my rule is y opposite x. So here's my complete rule. All right, let's look at number 2. The coordinates of triangle ABC are 3, 1, 5, 2, and 1, 7. It is reflected across the x-axis. And something, if you'll remember, if it's reflecting across the x-axis, that means the x stays the same. Only the y's become opposite. And likewise, if we were reflecting over the y-axis, the y stays the same and the x becomes the opposite. So I could, if I had a graph paper, like you will in the STAAR test, you could actually plot all these points. Make your own little coordinate plane, plot the points, reflect them, flip them over that x-axis, and then get your new points, like we did here, to describe your rule. But if you could remember that x stays the same, our rule, as always, starts out with our original coordinates, goes through our reflection process, and it comes out x stays the same, so then y becomes the opposite. There's my rule. X stays the same, y becomes the opposite. If we were reflecting over the y-axis again, the y would stay the same, the x would become the opposite. All right, let's look at number 3. Number 3 says the coordinates of triangle ABC are 2, 11, negative 5, 2, and 6, 8. It is translated. So now we're just going to be sliding around. We're not flipping, we're not rotating, we're not turning. We're just sliding around. And we're sliding 2 units left and 4 units down. Well, if I'm moving left or left and right, is that an X move, an X-axis move, or is that a Y-axis move? Remember, our X-axis is here, our Y-axis is here. So if we're moving to the left, that's an X coordinate move. So this is an X move. And if we're going down, that would be like going up and down. That's vertical, like our Y-axis. So this is going to be a Y move. All right, so let's start devising our rule. Again, we always start out with XY, our original point. We're going through a translation process, and we end up with a new point. Well, now we have to figure out, these are just directions. So we have to tell it my X is going to move. If it moves 2 units to the left, that is going to be X minus 2. If it was to the right, that would be going to the positive on the X-axis. 4 units down, down is negative. So it would be Y minus 4. If we were moving up, then it would be Y plus 4. So again, there is my rule. X minus 2, Y minus 4. All right, now let's look at the last question. The last question says the figure on the graph was rotated, so we're talking about a turn, 180 degrees counterclockwise. What is the rule? Again, I don't have the rules memorized. You may not either. So therefore, when we don't have the rules memorized, what do? We use our patty paper to help us. All right, so the first thing, we're going to find a nice pretty point. I can use this one. And we want to write down that ordered pair. So the ordered pair is 1, negative 4. And it's going to go through a process of rotation, and then we're going to get a new ordered pair. So again, we can just use a piece of our patty paper, mark your origin and your point. And now if I'm rotating it 180 degrees, that is 2 rotations, because rotations are always in increments of 90. And it's counterclockwise, so it's going backwards the way a clock would run. So it would go to the left. All right, so rotating it once, 90 degrees to the left. Rotating it twice, 180 degrees to the left. Line back up your origin and write your new ordered pair. In this case, you can see it is at -1, +4. -1, +4. All right, now that we see these two ordered pairs, we can look at their relationship to devise the rule. We know we always start out with x, y, going through the process of rotation, and then what happens? Well, first of all, did my numbers flip-flop? Did the 1 and 4 flip places? No, it didn't. So I know my x and y is in the same order. Now I just need to find out which ones changed to the opposite. I started positive, so I'm going to end negative. So that became opposite. So opposite x. Next I have -4, and that's going to change to a +4. So I also have -y, or excuse me, opposite y. Okay, so again, we're looking at my x's became opposite, positive to negative, opposite x. My y started negative, it changed to its opposite, +4. So it changed to its opposite, so we have opposite y. So here is my rule, opposite x, opposite y. All right, so that was a quick review of what we had learned about transformations. Now let's flip over to equations. All right, so equations. Here's a word problem, and let's read it. Taxi A charges a base rate of $5 plus 35 cents per mile. Taxi B charges a base rate of $2 plus 45 cents per mile. How many miles must be driven in order for the cost of Taxi A and Taxi B to be the same? So I need them equal to each other. So I'm going to come over here, and first I'm going to make my labels. Taxi A, we want it to be equal to or the same as Taxi B. All right, so next we need to go find the information to make our equation. So Taxi A we wrote first, so let's go look up information for Taxi A. $5 plus 35 cents per mile. This per mile right here, that's where you put your variable. So 35 cents times each mile. So when we write this, we could write this as 5 plus 0.35x. Or you could use M for mile. It doesn't matter what letter you use. Taxi B. Taxi B has $2 plus 45 cents per mile. So that's going to be 2 plus 0.45x. So now we just need to solve the equation. Remember, we want to get variables to one side, numbers or constants to the other. Well, when I look at my two variables, I first look at which variable has more. I see that 0.45 is larger, so I'm going to keep my variables on this right-hand side, which means I need to move 0.35x. Because this is a positive, the opposite of positive is negative, or subtracting 0.35x. But what we do to one side, we have to do to the other. That just makes 0 pairs. Positive 0.35x's and negative 0.35x's make a 0 pair. So all we have left is our 5 is equal to 2 plus 0.45 minus 0.35 would be 0.1x, 1/10. 45 hundredths minus 35 hundredths gives me 10 hundredths, or 1/10. So now that we have all our variables on one side, we need to move this 2 to the left-hand side. We need to do the inverse operation. So we're going to subtract 2 from both sides. Again, that makes a 0 pair. Positive 2, negative 2 makes 0 pairs. I've got to come up here to this next line. I'm out of room. 5 minus 2 gives me 3 is equal to 1/10x. And again, we want to get x isolated by itself. And this says 1/10 times x. So the opposite of multiplication is to divide by 1/10. Divide by 1/10. That cancels out to 1. So I have x equals 3 divided by 1/10. When it comes to decimals, don't be a hero. Use your resources. If you have calculators, use your calculator. Because we're not taking 3 divided by 1. It's not 3. I'm taking 3 divided by 1/10. So a little tiny piece of 1. So my answer is 30. So that means it will take 30 miles before the price of taxi A and taxi B are the same amount. So it'll take 30 miles before they're the same amount. All right, let's look at number 2. On number 2, we're not going to solve it because we don't have a lot of room, but I do need to make the equation. We need to take this pictorial model and generate an equation. Well, on this left side, I see I have a negative x, a negative x, and a negative x. So I have a total of negative 3 x's, because I have 3 negative x's. And then I have 1, 2, 3, 4, 5, 6 ones, and they're all positive. So plus 6. That's going to be equal to, and now we do the right side. I have 4 x's, and they're all positive. And then I have 8 negatives, so minus 8. Again, if we were to solve this, you would move variables to one side, constants to the other. All right, let's go down to number 3. Two angles have measures of x plus 14 degrees and 3x plus 15 degrees. What value of x will make the angles congruent? What does congruent mean? It means equal. It means the same measurement. The same measure, or equal. So what we're going to do is we're going to put both of these angle measurements and we're going to set them equal to each other because we want them to be congruent or equal to each other. So x plus 14 is equal to 3x minus 15. All right, let's solve it. Again, we want variables to one side, constants, or in other words, numbers to the other. Again, I like to look at my variables and see which side has more variables. In this case, it is on the right side, so I'm going to leave them here. I'm going to move this one. This is a positive x, so the opposite of a positive x is negative, or subtracting x from both sides. Positive x, negative x makes a zero pair. I'm left with 14 is equal to 3 x's minus an x is 2x, and then bring down minus 15. So now my variables are on the right, so my numbers need to go on the left. So I have to move negative 15. So the opposite of subtracting 15 is to add 15. But what I do to one side, I do to the other. 15 negatives and 15 positives make a zero pair. I'm left with 2x is equal to 14 plus 15 gives me 29. And then the final step to get x by itself, remember this is multiplication, 2 times x. So we're going to divide by 2. That cancels. Divide by 2. 2 divided by 2 is 1, so that's just 1x. 29 divided by 2 is 14.5. 14 and 5/10. So when x is equal to 14 and 5/10, both of these two angle measures will be congruent. All right, our last one. What value of x makes the equation true? That's just a fancy way. That's just a fancy way to say solve for x. Find the value of x. All right, so we're going to draw that line down the equal sign. Remember, variables to one side, numbers to the other. So let's look at our variables. I have 6/10 x's and 1/10 x's. So in this instance, my left side has more. Because my left side has more, I'm going to move the right side. I'm going to move this 0.1x. It's positive, so the opposite is to subtract 0.1x from both sides. That cancels out, makes zero pairs. So 6/10 minus 1/10 is 5/10 x plus 7 equals -8. All right, now we've got our variables all on the left side. We need to move this 7 to the right. We do that, the opposite of adding 7 is subtracting 7. But we have to do it to both sides. 7 positives, 7 negatives make 0 pairs. So I'm left with 5/10 x is equal to, now this is where people make the mistake. This is the same thing as -8 minus 7. -8 plus a -7. I'm standing at -8 on my number line, and I'm going 7 steps further in the negative direction. So I get -15. -8's two negatives, add them together and keep the sign, -15. Final step would be to divide by 0.5 from both sides. 0.5 divided by 0.5 is 1, so 1x is just x. -15 divided by 5/10 is -30. So -30 would be what I could plug in here and make each left and right sides equivalent to each other.